So good morning everybody, myself Acharya Vishvendra. I shall be explaining a worksheet based on kinetic energy today. So let's begin with things in proper perspectives. So here is the sheet. Let's start with that. The first question is dimensions of kinetic energy. So it is m1 L2 T minus 2. Next is SI unit of kinetic energy. It is joule or kg meter square second minus 2. Third is CGS unit of kinetic energy. It is erg or gram centimeter square second minus 2. Then there is a relation between joule and erg, as 1 joule is equal to 10 is to power 7 erg, or equivalently 1 erg is equal to 10 is to power minus 7 joule. Now there is a concept of kinetic energy. It is equal to half mv square. M is the mass and v is the speed of the body. Now let's study some graphs related to kinetic energy. So the first graph is between kinetic energy and mass. So we can say that if speed is constant, then kinetic energy is proportional to mass. So the graph will be a straight line. Now if we need to find angle theta, then we can say that tan theta is equal to k by m, which comes out to be v square by 2, where v is the speed of that particular body. Next is graph between k and m. So we can see there are three graphs, and theta 3 is greater than theta 2 greater than theta 1, which implies tan theta 3 is greater than tan theta 2 greater than tan theta 1. Now since tan theta proportional to v square, so this inequality signifies that v3 greater than v2 greater than v1. So we can say that 3 is fastest and 1 is the slowest. Next is we need to draw some graph between kinetic energy and speed under constant mass. So we can say that kinetic energy is proportional to v square. So graph will be a parabola turning toward k axis. Here also graph is a parabola, but it will turn toward the k axis. Now in next question we are being given three graphs, 1, 2 and 3, and we need to find which graph corresponds to the maximum mass. So if we drop a line perpendicular to v axis, that means on all the three curves v is gonna be same. So if v is same, then we can say that kinetic energy is proportional to m. And we can see that corresponding to graph 1, suppose this is k1 and this is k2. So we can see that k1 is greater than k2 greater than k3. Now since k is greater than 1 m, so k is proportional to m, so it signifies that the graph corresponding to 1 corresponds to the largest mass. So the relation between these terms will be m1 greater than m2 greater than m3. In the similar way, if we draw k along the x-axis, then we draw line v perpendicular to v. So is v is gonna be same on all the three things. So we can say that on graph 1 it is k1, on graph 2 it is k2. So similarly we can say that k proportional to m for same speed, and since k1 is greater than k2 is greater than k3, so we can say that m1 is greater than m2 greater than m3. So m1 is heaviest and m2 is the lightest. Next is the relation between k and v square. So we assume that v square is x, so k is proportional to x. Graph will be a straight line. If we find tan theta, it is k by v square. Solving this, we get tan theta is equal to m by 2. Next is we have a graph of k versus v square for three different cases, 1, 2 and 3. As we can see from the graph, theta 3 is greater than theta 2 greater than theta 1, which means tan theta 3 is greater than tan theta 2 greater than tan theta 1, which means m3 greater than m2 greater than m1. Next is there is a relation between mass, momentum and kinetic energy using this equation, k is equals to p square by 2m. Next is if we draw graph between k and p, so k is proportional to p square for constant mass. So we can say that graph will be parabola and turning toward the k axis like this. Next is if we draw graph between k and p square, we assume that p square is equal to x. So k is gonna be proportional to x, so graph will be a straight line. Next is in this particular graph, if we draw find tan theta, so tan theta will be k by p square. On solving we get 1 by 2m. So I hope it will optimize your time and energy for preparing the basic of kinetic energy. Thank you and have a nice day.